We'd like to look at this linear system. X prime is 2x plus 3y. Y prime is equal to minus x. We know how to solve systems like this, but we would like to decide the behavior here fairly quickly. We think of this system as being given by this matrix. X prime is 2x plus 3y. Y prime is minus x plus 0y. The characteristic polynomial for this matrix is lambda squared minus 2 lambda plus 3 is equal to 1. And we find that the eigenvalues are 1 plus or minus the square root of 2 times the square root of minus 1. And so if we think of the determinant, it's 3 and the trace is 2. So the trace is positive, the determinant is also positive, which of course tells us that the two eigenvalues either have the same sign or their product is positive one way or the other. A quarter of the trace squared is a quarter times 4, so that's 1. That's actually less than the determinant, so this tells us that it's a spiral source. In fact, you could see that just from the eigenvalue itself. This says there's an e to the t factor, so there's an expansion, and this tells us that it's spiraling. Let's draw a bit of the phase portrait for this to see which direction the spiraling goes. The system that we were looking at is this one. We decided that it was a spiral source, meaning moving out, and here's a bit of a picture of it. If I pick a point, I've just picked 1, 2, just as a test point, and I calculate what x prime and y prime are at that point, I find that that's 8 minus 1, which means that x is increasing by a fair bit, and y is decreasing fairly slowly by comparison. And so the vector from the vector field points like this, and that's clearly going clockwise. And so you can see that the spirals are going like that.